Welcome to episode 24 of the Pulse of Physiology. I'm your host, Dr. Jim Davis, and today we're exploring the incredible world of hormones, starting with those produced by the pituitary gland, followed by the adrenal gland, and finally some of the other endocrine glands. These hormones regulate nearly every function in the body, from growth and metabolism to stress responses and reproduction. In our next episode, we'll begin our journey into the muscular system, focusing on the functions and basic anatomy of something called a sarcomere as well as the neuromuscular junction. But for now, let's jump right into hormones. Now, the pituitary gland, often referred to as the master gland, plays a crucial role in regulating various other endocrine glands and tissues. This gland is divided into two parts, the anterior pituitary and the posterior pituitary. The anterior pituitary produces hormones such as growth hormone, which is stimulated by growth hormone releasing hormone from the hypothalamus. Growth hormone targets bone, muscle, and the liver, promoting bone growth, increased muscle mass, and gluconeogenesis, or the formation of glucose, in the liver. Thyroid stimulating hormone, or TSH, is another pituitary hormone and is stimulated by thyrotropin releasing hormone, or TRH, and acts on the thyroid gland to encourage the production of thyroid hormones T3 and T4. Additionally, the anterior pituitary secretes adrenocorticotropic hormone, or ACTH, which is triggered by corticotropin-releasing hormone, CRH. ACTH targets the adrenal cortex, stimulating the release of cortisol to manage stress and maintain glucose levels. Luteinizing hormone, or LH, and follicle-stimulating hormone, FSH, both regulated by gonadotropin-releasing hormone, or GnRH, and they both influence reproductive processes by targeting the ovaries in females and testes in males. They promote ovulation and testosterone production, as well as follicle development and spermatogenesis. Lastly, prolactin, controlled by low dopamine levels, promotes milk production in the mammary glands in response to a suckling infant or elevated estrogen levels. The posterior pituitary functions differently, storing and releasing hormones produced in the hypothalamus. Oxytocin, a posterior pituitary hormone, is released in response to cervical stretch or a suckling baby. It targets the uterus to promote contractions during childbirth and the mammary glands to facilitate milk ejection. Vasopressin, or antidiuretic hormone, is another posterior pituitary hormone released in response to increased plasma or osmolarity. Remember, osmolarity just means concentration. This hormone targets the kidneys to promote water reabsorption and helps maintain blood pressure through vasoconstriction. Now let's turn our attention to the adrenal gland, which consists of two distinct regions, the adrenal cortex and the adrenal medulla. The adrenal cortex produces cortisol in response to ACTH stimulation, which we talked about a moment ago. Cortisol targets the liver, muscle, and fat, increasing blood glucose levels while suppressing immune responses and aiding in stress management. Aldosterone, which is another hormone from the adrenal cortex, is released in response to low blood pressure, high potassium, or low sodium levels. This hormone targets the kidneys, promoting sodium reabsorption and potassium excretion to increase blood pressure. Meanwhile, the adrenal medulla produces epinephrine in response to stress or strong emotions. Epinephrine enhances the fight or flight response by increasing heart rate, blood pressure, and metabolism. Finally, let's examine the hormones from other endocrine glands. The thyroid gland produces the hormones T3 and T4 in response to thyroid-stimulating hormone from the anterior pituitary, which we spoke about during the beginning. T3 and T4 target nearly all cells in the body to increase metabolic rate and promote energy utilization. Additionally, the thyroid glands secrete calcitonin when blood calcium levels are high. Calcitonin targets bones and kidneys to lower bone calcium levels by promoting calcium deposition, think of deposit, into the bones and reducing calcium reabsorption in the kidneys. The parathyroid gland, in contrast, releases parathyroid hormone when blood calcium levels are low. Parathyroid hormone increases blood calcium by promoting bone reabsorption, enhancing calcium reabsorption in the kidneys, and activating vitamin D to improve calcium absorption in the intestines. The pancreas also plays a crucial endocrine role by regulating blood glucose levels. Insulin is released when blood glucose levels are high, targeting the liver, muscle, and fat to promote glucose uptake and lower blood glucose. Conversely, glucagon is released in response to low blood glucose, and it targets the liver to stimulate glycogen breakdown, which increases blood glucose levels. To summarize, the pituitary gland acts as the master regulator, regulating hormones that influence growth, metabolism, reproduction, and stress management. The adrenal gland complements these functions by producing hormones critical for stress responses, blood pressure regulation, and energy mobilization. Other endocrine glands, including the thyroid, parathyroid, and pancreas, secrete hormones that manage calcium balance, metabolism, and glucose regulation. Together, these hormones maintain the body's intricate balance and ensure optimal functioning. That's all for episode 24 of Pulse of Physiology. I hope this comprehensive overview has enhanced your understanding of the body's key hormones. Join me next time for episode 25, where we'll begin exploring the muscular system, starting with basic anatomy of a sarcomere and the neuromuscular junction. Until then, keep questioning, keep exploring, and stay curious.